what we are doing. So, new topic today. This is finance and recursion. So, finance and recursion. So, this topic is probably the hardest topic we'll do. It is the hardest topic we'll do. So, there's a lot of real little nitty-gritty technical things. It's really important that we get them correct so that our answers are correct. And there's lots of new language as well. So it's important that we understand the different definitions, what the question is asking, and what we need to do. So when we did our last one, when we did our core, sometimes there was like one or two ways we could, do different things. Whereas when we're doing this one, if I ask to do it in a specific way, you have to do it in that way, otherwise you won't get the marks, even if you get the right answer. So it's really important that we understand exactly what we need to do and how we need to do it. So we are starting with sequences. So a list of numbers written in succession is called a sequence. So this can be any list of numbers. They don't have to be in order. It's just a list of numbers and it's called a sequence. Each number of a sequence is called a term. And a term is usually written as Tn, and that n is below the T. When we have an unknown term or number, we use the letter n. So if we were talking about something called the first term, we'd call it T1. If we're talking about the fifth term, we'd call it T5. If we're talking about the nth term, or a term we don't know, is talking about the sequence in general, we're talking about Tn. Does that make sense? So we just use n for number. We just use n when we don't know what number term we're talking about. And if we've got a sequence that continues indefinitely, we're going to use three little dots to say, this sequence keeps going. Some sequences won't. Some sequences will have a definite end. Some will keep going. Any questions so far? Cool. All right. If a sequence does not have a pattern, it is called a random sequence. And if there is a pattern, it is called a rule-based sequence. For it to follow a pattern, it must be following some sort of rule. So if we were looking at this sequence here, 2, 4, 6, 8, what would be the rule to get to the next number?
Plus 2.
Yeah, add 2. Yep, so that would be the rule for it. Any questions so far? Cool, can I go down? Yep, cool. All right. Button fell off my jacket this morning. It's really annoying me. It's like a wing flying. I hope his skirts stay up.
Every morning. Is that your real hair?
Yeah, it was.
I read it in the morning and I was like, it's just in a vegan shirt. I saw when I drove on.
Yeah, it's totally starting a trend.
You realise every time I
Then I washed it and I was like, oh, I'll smooth again.
Yes. Every time.
Alright, so writing rule-based sequences. So, sequences always have a starting value and a rule. So the starting value tells us where to start from, and the rule tells us what to do to the starting value. So if we were given the question, write down the first 5 terms of a sequence with a starting value of 6, and the rule, add 4 to each term. So our T1, which would be our first term, would be 6, because that's where we're starting. And the rule is just to add 4. So to find T2, we would have 6 plus 4, which would be 10. And then to find T3, we would have 10 plus 4, which would be 14.
Do you have to do that or can you just write them?
If it's asking like this, you can just write the sequence.
Okay. So
Yep.
we just wrote 6, 10.
Yep, so if you've just got 6, 10, 14, 18, 22, that's fine. When the question just asks, write down the first 5 terms. If it's just asking write down the first 5 terms, it just means just write it down. We'll get through some other sort of things, and then you'll be able to understand. Okay, well, how else can we write it? All right. So the next one, same thing. So write down the first 5 terms of a sequence with a starting value of 5, and the rule: double the number, then subtract 3. If you want to do this on your calculator and not show you working out, that's fine as well. So you can just put in your numbers. Like that, that's fine. Any questions about that? All good?
I'm not sure I'm right though. So it's 11 times 2.
22, if I got the wrong number.
I think it's
Yeah,
19.
19.
Oh, it is 19.
It is 19. Sorry, my bad. 35, is it?
Did you write 19?
All right, are we good to go on to the next one? Yep, all good?
Yeah.
Cool. Okay, so the next thing we're looking at is recurrence relations. And this is pretty much just how we can present or how we can write a sequence. So if the question is talking about use the recurrence relation to do anything, we need to write it in this sort of format. Really important, because if you don't use a recurrence relation, even if you get the right answer, you won't get the marks. So a recurrence relation is a mathematical way to generate a sequence. And like a sequence, it always has a starting point, which is the value we start at, and a rule, which is what we are doing to the starting value to get our next terms. And there are 2 main types of rules. We have arithmetic, which is when we're adding and subtracting. And when we're adding or subtracting, our values increase or decrease by the exact same value. So we keep adding 2 or taking away 4. That number stays the same. Bless you. Geometric is multiplying. So when we are using a geometric sequence, our values increase or decrease by the same percentage. So it would be like multiplying by 2. So we're going up. Every number we multiply by 2. And iteration means each time we apply the rule. That may be a word that pops up in questions. All right, any questions? Cool. Okay, and we have a few different formulas. We have 3. All right, when we are using arithmetic sequences, so when we're adding or subtracting, our recurrence relation is written in this format. You'll often see it as the letter V, but it can be any letter. So if we were talking about party pies, that's the first thing that came to my head, we could use the letter P instead. All right, but generally you will see it as V, but it can change. The things that won't change is N, the term we're finding, which is what we talked about before. When we've got a term that we don't know what number it is yet, we're just going to use the letter N for number. A is our starting value, so our first number. And D is the rule we are applying. So because if it's arithmetic, there's only 2 types of rules we will be applying. We'll either be adding or we will be subtracting. So this is only for adding and subtracting. So V0 equals our starting number. And Vn plus 1 equals Vn plus or minus D. And what that means is that the term we have at the moment, to get to the next term, I need to add the rule to the term that I've already got. And we'll go through some examples which will make it a little bit clearer. Really important that this bit always goes in front. If you write this bit and put this bit at the back, you won't get the marks. This bit needs to be at the front. All right, for the geometric sequence, similar, but instead of a D, we've got an R. And R stands for ratio. Oh, and up here, D stood for difference. So R stands for ratio. So what are we going up by? Are we multiplying by 2? Are we multiplying by 0.2? Or what are we going down by? So, same start. V0 equals A. This bit is exactly the same. Only difference is, instead of plussing or minusing D, we're multiplying by R. So that's the difference between these two. Yep. Yep.
Would the question tell you, like, which number was going to be R?
It would either tell you or you would have to find it. At the moment, it will tell you. Yep. We'll get into how to find it.
Why is there no dividing? This would make sense.
There's no dividing because instead of dividing, we multiply by a decimal.
Yeah.
So multiply by 0.5, it's the same as dividing by 2. Yeah. Any questions so far? All right. Can I go down?
Wait, I don't get when it says D, and it means like the rule that we're applying.
Which
one
bit?
One has R and one has D.
Yep. So it depends on what type of sequence we have. If we have a geometric sequence, we're using a ratio.
Okay.
If we're using an arithmetic sequence, we have a difference.
But is it still?
It's sort of like the same sort of thing. It's what we are doing to the rule.
Okay.
But if it's arithmetic, it's just called D because it's the difference. We're either going up or down by the same number, so there is a difference. Whereas this one, we're multiplying by something, so we're going up or down by a ratio. And that's why they've got different letters. But essentially, it's the rule sort of thing. It's what we are doing. Yeah.
What does it say when it says let Vn be the term in the sequence after?
Yep, so it's saying, so Vn be the term in the sequence after n iterations. So we don't know how many we have, so we're just using n. If this was let V2 be the term in the sequence, that would be after 2 iterations. So after 2 times we've done it. Does that make sense?
Yeah.
Cool. Any more questions? Awesome. Okay, so yeah.
Where it says Vn plus 1 equals R, is that x or times? You might need to.
Oh, here.
Yeah.
This bit
Yeah.
or this bit? That bit. That's times.
Times.
All right. Sometimes we will get a sequence like we had in the example before, where we might multiply then subtract, or we might multiply then add. So we're doing both. It's a combined sequence. So we'll be doing the geometric and the arithmetic to both of them. So the way we write that, start is exactly the same. We're putting in our ratio, which is the geometric rule we are applying at the start. That's a times, not an x, at the start. And then putting in the arithmetic part of the rule at the end. So the plus or the minus at the end, with our Vn in the middle. So that's the formula for that one. Any questions about that?
Yes.
Yep.
Does it matter which way you order the variables? Like, does it always have to be R, Vn plus minus D, or can it be like Vn times R plus minus
That would be okay.
Yeah.
Yeah.
What do you use this for?
So if you've got a geometric and an arithmetic bit, so like the one before we had times by 2 take away 3. So we'd have the times by 2 take away 3.
Why'd you put it on your eyes? Because they were red.
You know how they go red?
You know how they can change to any letter? Is it just best to leave it as V?
Unless it says so otherwise in the question. Okay, so a couple of points for our recursion. This bit here means our starting value. So our V0 is always our starting value. It's what the number is when we haven't done anything to it. It is our original value. This is the rule. So if we were looking at this, the main part we need to look at is this part here. So if this was our recursion relation, this would mean we're starting at 10 and we're plussing 5 each time. And that's all that means. Don't let this jargon in front of it confuse you. It's important that you write it, but don't let it confuse you. So the term that we have plus the next, we're trying to find the next term.
So it would be 15.
Oh, so it'd be 2 if it was like 5, 7.
So
It just means the term.
it just means the term, just means the next term.
N plus 1?
Yes.
Because
Yep.
it's the next term.
Yep, it's the next term. Yep.
Rule for generating the next term.
Thanks.
So then to put them both together, so the starting value and the rule for generating the next term, we put them together and that's our recurrence relation. Also good?
Yeah.
Yep, cool. Alright, so
Don't write that.
that it is confusing. It is confusing.
Could say N plus 3 next time.
That will always say plus
That'd
1.
be the third.
Okay, so question says generate the first 5 terms of the sequence defined by the recurrence relation V0 equals 9, Vn plus 1 equals Vn take 4. Showing the values for the first 4 iterations. So this is saying find the first 5 terms, and this is saying the first 4 iterations. So what this means, the first 5 terms includes our V0. But remember our V0, we haven't done anything to it. So we can start with our V0. What is it? 9, sorry. Yep,
Do you have to make it like a little zero all the time?
yes.
Zero B zero.
That needs to be little.
Do you always put V0 when it's
Yes. Alright, and then it's saying the first 4 iterations. So the first 4 iterations would be the first 4 numbers that have had something done to them, which would be the rule. Is that making sense? So altogether, there is 5 terms, because we've got our V0 plus our first 4
So it'd be
iterations.
9 take away 4.
Yes, but how we write it is really important. So, for our V1, we need to show that it is V0 and the rule. So our rule for this one is just take away 4, but we need to show that we've got take away 4.
So do you have to show it working out?
Yes. So we've got 9, take 4. Yeah,
How do you know whether or not to include the V0?
you will. If it's,
Always.
yeah, the first 5 terms, this is the first term. Yeah,
So always.
yeah. So then we've got V2, which will equal our V1, take 4.
Do
Can we
you
just write 9 minus 4? Do we have to write 0 minus 4? Like twice how you've done it? Do we have to spread it out that much?
That's a good question. Let me check.
So it's going to
Let me check. Let me just double check.
So 5 minus 4.
On here it says yes.
So write it like that?
Yep.
Okay.
So you do always have to show you working out for every.
As far as I can see, yes. Yep.
Wouldn't it be 5 take away 4?
Yep, thank you very much. That's why my answer is wrong. So I'm like, That's better. Thank you.
Say it out loud. I can't. Me too. I love when there's 2 negatives. Because it's easier. Because then it's easier to do just 2. Yeah, I agree. Because when it's like 5 minus 5.
Then we can finish the answer by saying the sequence is 9, 5, 1, -3, -7.
This is the hard one.
Yes.
Could you say like V0 is V1, or do you always have to say V0 is V0? Do you know what I mean?
V0 is V0. Yeah. Any questions? Cool. Let me copy that down.
Do we have to write the sequences? Or-
Yeah. Yeah.
So then you should always write
The sequences, yeah.
It's 5 and 4. It's 5 is that's right. Alright, that's right. Do you have them now?
I really want to go on the sneak.
But then I can't.
Can I go down?
I can.
Yep.
You can.
Say it too much, you have to show the
I don't know what it's going to be. Right, everything. You don't.
Okay, and then the last bit is
pancake.
Yeah, sorry. Sorry, just
It's not like that. It's not good one. It's not as competitive.
doing it on your calculator.
It's cool.
So, get your calculator out. So, a sequence is generated by the recursion relation V0 equals 300, Vn plus 1 equals 0.5, Vn take 9. So, what this is saying is use your calculator to determine how many of the terms in this sequence are positive. So, this means we need to keep finding our terms until we find a term that is negative. So there's a couple of bits to this rule. So what is our actual rule here? We're starting at 300. That's what we're starting with. And what are we doing to 300?
Do we have to write VO equals 300? You know how before you said you'll lose marks?
Not if it says to determine how many terms in this sequence are positive. Because it's asking something else. It's not saying use this rule or recursion to find it. It's just saying how many. So you can just show you.
Okay.
Yeah.
But before you need to write that.
Yes.
Okay. Yeah.
So we're starting at 300, and what are we doing to this rule? Yep, what are we multiplying by? Yep. Are we doing anything else? Yep, and then we're taking away 9. So there are two parts to this. So in your calculator, best way to do this is type in the number 300. So type in the number 300 and then press enter. So once you've pressed enter, then just type in times 0.5 take 9 and it should come up with answer times 0.5 take 9. And then if you keep pressing enter, it will come up with the next terms. And you shouldn't have to keep entering it. You should just be able to keep pressing enter.
That's so much easier.
Hey? So type in 300, press enter.
Because you do it wrong.
Yeah. And then type in the rule. So times 0.5 take 9.
Oh, right. Yeah. Okay.
And then you just keep pressing enter till you find a negative.
Yep.
Do you have to write down
No, well, it just says determine how many of these terms in the sequence are positive. Yep. Plus the first one.
Plus 300. 1, 2, 3, 4, 5, 6.
Okay.
Is that wrong?
Yep.
Oh,
Because
no, I
yours
did it.
isn't.
Yeah,
Yeah.
sorry.
Yep. And you haven't got the. Yeah. Yep. Good.
Sorry, I was counting.
There should be 5.
We need to do this.
There should be 5 because we have 300. We have 141, 61.5, 21.75, and 1.875. And our next term after that is negative 8.625. So we've got 1, 2, 3, 4, 5.
Do you have to write V0 and V1?
No, not for this one because it's all it's asking is how many are positive. So it's not asking you to show the rule or anything like that. It's asking how many are positive.
Are they dash points or negatives? Okay, just asking.
Oh, that was just me counting.
Can you say V0, 1, 2, 3, 4?
Yeah, you can if you want. Yeah.
Would it matter if you wrote them in fractions?
No, that should be fine. Yep. There are 5 terms.
Would you have to write them
Unless it says so.
Do you always include V0 as one term?
Yes. So there are 5 terms in this sequence that are positive. Any questions? Cool. All right, so that's 8A and 8B. And you can make a start on them.